This is Vicki Gaines. Thanks for stopping by. We are dealing with slope and rate of change. Let's learn something new. Rate of change. So that's what we're going to find, that and slope in this lesson. Warm up. During exercise, a person's maximum heart rate, R, in beats per minute is estimated by R equals 220 minus A. A is the person's age in years. What's the maximum heart rate for a 32-year-old while exercising? So we have the expression there for the heart rate in beats per minute, and we have the person's age. So we just plug it in, calculate, we get our answer C, 188 beats per minute. Another warm-up. Initial fee to join a gym is $200. That we pay once. It costs $55 per month. That's our monthly rate to have a membership. Write a function for the total cost, C of X, of having a membership for X months. And what is the cost for having a membership for 18 months? Let's see. So we only pay the 200 once, and the 55 is per month, which is X. So that is looking like B, 200 plus 55X. But we need to plug in 18 months. So plug in 18 in place of X and calculate. And we get option B. Cost to have the membership for X months is 200 plus 55X, and for the 18 months, it is $1,190. Yikes! Find the rate of change. Rate of change is a ratio that compares how much one quantity changes on average relative to the change of another quantity. And we're going to be determining the slope of a line. The slope of a line is a ratio of the change in the y coordinates to the change in the x coordinates. So we have a little diagram over there. M stands for slope, and that triangle is actually a Greek letter delta, and it means change in y over change in x. So slope is rise over run. Rise is a change in y's. Y-axis is vertical, it's up or down, and run is our x-axis that runs left or right. So change in y over change in x, or if we're dealing with 2 points, we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Make sure you're getting the difference on top and dividing by the difference on bottom. Be careful putting that in a calculator. Real world example, constant rate of change, college admissions, 2016, wow, it's 2026 right now. This is old data. 31,388 first-time college students applied to a state university. In 2014, 25,949 students applied. Find the rate of change in the number of first-time college students applying for admission from 2014 to 2016. So we're going to do our rate of change. Change in y over change in x. And our points are x, y. So 2016 is the year. Those are our x's. And our 31,388 is the y value. For our other point, it was the 2014 was our year, that's our x, and 25,949 was our corresponding y. So we need to do the change in y's over the change in x's and calculate. We get 5,439 over 2, and when we calculate, That is 2,719.5 is the increase per year. Can't have half a student though, so be careful with that. Real world example one, find the rate of change for the data in the table. Remember, it's change in y's over the change in the x's. So on the left-hand side, here's our x's. We're going from 2 to 4, which is up 2, 4 to 8, up 4, 8 to 12, up 4, and 12 to 14 is a change in 2. 8 to 16, change in 8. 16 to 32, change in 16. Same thing here, going from 32 to 48, we're going up by 16, and 48 to 56 is going up by 8. So if we look on a corresponding change on the right to the change on the left, we have an 8 feet for 2 minutes, which is 4 feet per minute. Let's try another one. 16 on the right matches with 4 on the left, and 16 feet in 4 minutes is 4 feet per minute. So we have the same rate of change, that is C, 4 feet per minute. Example number 2, average rate of change, business. Refer to the graph below, which shows data on the fastest growing restaurant chain in the United States during the time period on the graph. Find the rate of change of the number of stores from 2001 to 2006. Way old data. Wow. Let's see, here's point x sub 1, y sub 1. That's where we're starting. And this is where we're ending up. And our formula for slope is the change in y over the change in x. So y2 minus y1 over x2 minus x1. Let's put those in. So 34 minus 7 over 2006 minus 2001. We get 27 over 5. And when we put it in our calculator to calculate, we get 5.4 thousand stores per year. Because notice on the graph, it is stores in thousands. Real world example number 2, computers. Refer to the graph. Find the average rate of change of the percent of households with computers in the United States from 2000 to 2004. Wow, old data. That's okay. We can still find rate of change. So we have our first point, which is 2000, 61%. And our second point is for 2004, and that's 74%. So change in the y's over change in the x's. So we're going to subtract the 74, and that is percent, minus 61%. Because we're looking at percent per year, and years is on the bottom. 2004 minus 2000. That's 13% in 4 years. And if we calculate that, that's 3.25% per year. Looking at our multiple choice, it is an increase, but there's nothing in the diagram that's dealing with million at all. It is percent per year. So C is our answer. 3.25% per year is the rate of change. Find slope using those coordinates. The line passes through those 2 points. There's our x sub 1, y sub 1, x sub 2, y sub 2. And slope, of course, is change in y over change in x's. And we have our formulas there. Let's plug our values in. So we have negative 2 minus 4. Those are subtracting y2 minus y1. Over 1 minus negative 1, which is the x2 minus the x1. And now we need to simplify. That's negative 6 over 2, or negative 3. So there's our slope. Find the slope of the line that passes through those 2 points, 9, negative 3, and 2, 7. There's our first point, second point. Really doesn't matter which is which, but I just took them left to right. To find the slope, we want the change in y's over the change in x's. So y sub 2 minus y sub 1, which is going to be 7 minus negative 3. And then x sub 2 minus x sub 1, which is 2 minus 9. So plug in those values in. 7 minus negative 3 is going to be 10, and 2 minus 9 is 7. So negative 10 sevenths is our slope, and that is option B. Next one, find the slope of the line. Slope is the change in y's over the change in the x's. And there's our first point, second point. I'm going to calculate. We could count, but I'm going to calculate using our formula. So y2 is 1 minus y sub 1 is 0. And x sub 2 is 1 minus x sub 1 is negative 1. And when we calculate, we get 1/2. So that's the slope of that line. We went up 1 and right 2. Also 1 over 2. Rise over run. Find the slope of this line. I'm going to use the formula again. So we're going to be subtracting the difference of the y's over the difference of the x's. So y sub 2 is 0 minus y sub 1 is 2. X sub 2 is 3 minus x sub 1 is negative 6. So 0 minus 2 over 3 minus negative 6. Let's simplify. We get negative 2 over 9, and that's our answer, A. Tether. A tether is tied tautly to the top of a pole as shown. What is the slope of the tether? So that's going to be rise over run. And our change in y's, our rise, is going to be the 9 feet. And our run is going to be the 12 feet. So 9 over 12 reduce, we get 3/4. So that's our slope. Number 2, aviation. An airplane descends along a straight line path with a slope of negative 0.1 to land at an airport. Use the information in the diagram to determine the initial height of the airplane. So that's what we're looking for. And slope is a change in y's over the change in x's, or rise over run. There's our rise and there's our run. So x over 50. But we know what that slope is supposed to be. It's supposed to be negative because they're going down to the airport. Negative 0.1. So let's write that equation. And we're going to need to multiply both sides by 50 to solve this equation. So there we go. Those will divide out. And x is going to be negative 0.1 times 50. So x is negative 5. So the initial height of the airplane is 5 miles above the ground. We have now finished slope and rate of change. Hope you learned something new. Until next time, see you later.